Sunday. Join NASA's OSIRIS-REx on September 24th to watch pieces of asteroid Bennu return to Earth for scientists to enjoy. $20 a seat, but you'll only need the edge.
On this episode of This Week in Space, clearly we're talking about bringing Stardust back to Earth with Anjani Polit, the Mission Implementation Systems Engineer for the OSIRIS-REx mission to asteroid Bennu. Stay with us.
Podcasts you love.
From people you trust.
This is TWiT.
This is This Week in Space, episode number 79, recorded on September 15th, 2023. Stardust, back from Bennu. This episode of This Week in Space is brought to you by Discourse, the online home for your community. Discourse makes it easy to have meaningful conversations and collaborate anytime, anywhere. Visit discourse.org/twit to get 1 month free on all self-serve plans. And by our friends IT Pro TV, now ACI Learning. IT skills are outdated in about 18 months. Launch or advance your career today with quality, affordable, entertaining training. Individuals use code TWIT30 for 30% off a standard or premium individual IT Pro membership at go.acilearning.com/twit. Hello and welcome to another episode of This Week in Space, the Stardust Comes Back to Earth edition. I'm here today with the ineluctable Tariq Malik, editor-in-chief at space.com. How are you, sir?
Hello, did you say ineluctable? I mean,
ineluctable. It's kind of like undeniable. I, of course, am Rod Pyle, editor-in-chief at space.com, and I join Tariq here every week to bring you the best guests, including today we have the marvelous Anjani Polit, the Mission Implementation System Engineer for the OSIRIS-REx mission to asteroid Bennu, which will be returning a sample to Earth on September 24th, which is really exciting, and we're pretty sure she's really busy. How are you today?
I'm doing great. It's definitely a busy time for us on OSIRIS-REx.
Okay. Well, we really appreciate you joining us today. And I'm sorry to say, despite how thrilled we are that you joined us, I do have a space joke. I have to do my space joke. So, Tariq.
Yes, Rod.
We have a new space dad joke from the interwebs. What do they say about the asteroid that killed all the dinosaurs?
I do not know. What do they say?
You could say it killed many birds with one stone.
Is that an evolution joke too? Like a dino?
It's just a sad one. Okay, wait, let's try another one.
All right.
An asteroid measuring 1,600 meters is headed straight towards Earth. That's quite the milestone. Okay. Well, I didn't even get an audio sting for that. Oh, there are the crickets. All right.
Even Anjani didn't like that one. So
well, that's because she has taste, class,
that's
and
right.
education. So, as always, of course, we invite you to join Tariq's Giggle Gaggle and send us your best or worst space jokes. That was an example of a couple of not the best. And don't forget to do us a solid. Make sure to like, subscribe, and send us all your old savings bonds. Well, maybe not the last, but when you like and subscribe, it helps keep us on the air and bringing you this content for free. All right, on to headlines.
yes.
Wow, that's almost as old as I am. So, Tariq from space.com, we have a new report from our friends at NASA.
That's right. That's right. Hot off the presses, NASA's unidentified anomalous objects.
Phenomena.
What do we call them? Phenomena. Yeah. Study group had their first report this week, and they did not find aliens. Rod, I know that was a big surprise for you. I know that we're really sad about it, but NASA Chief Bill Nelson did say that what they did find out is that they don't know everything, and they are starting a new really targeted research program. And in fact, they named an actual director of UAP research to lead that effort. And the goal is to just use all of NASA's assets, things like Earth observation satellites, FAA reports on air traffic safety, and of course the DoD reports that they have as well for their sightings, to try to cross-reference everything and just find out what these phenomena actually are. So it sounds like it was like, we didn't find anything, but we still don't know what these reports are. So we're going to try to actually coordinate everything now type of a thing. I don't think any of us were actually expecting them to say that it was ET trying to say hello. But it was a nice, interesting move forward. And I'm not sure like what the next big thing will be until we hear what the director has to say.
Well, I just have to say, I got to give props to Bill Nelson. You know, we've seen a lot of NASA chiefs come and go over the years, but I think having a politician in charge, as we did with Jim Webb and Jim Bridenstine, is not a bad thing. He got a couple of really dopey questions from the press corps. I can say that because I don't work for NASA. A couple of them were sort of like, I can't believe that person just asked that. And he handled them with a great deal of grace, was firm, but reasonable and kind. And I think he handled that conference really well, as did everybody else in that panel.
And what you're seeing is definitely just taking everything really seriously and trying to take that tinfoil hat shine off the whole phenomena, because something is clearly sparking these reports from the military, on down, and finding out what they are. We would be good to know. We had that Chinese reconnaissance balloon,
right,
that kind of floated over, and you don't want to see that stuff come in all the time. And so this is just a way to kind of destigmatize the entire thing, I think.
All right, next up, and we're going to have to keep this short. This is probably worth an episode at some point, but we had yet another report out on SLS, and the news was not what we would have hoped for.
No, yeah, and actually Ars Technica, Eric Berger over at Ars Technica had a really good source for this story too, and Space.com, we wrote about it as well. But the GAO put out their the Government Accountability Office put out their report that basically admits that the SLS is not affordable. Based on the economics right now, because NASA is reusing a lot of old parts for the space launch system, things like the old space shuttle engines and whatnot, that they will eventually have to buy more and brand new versions of. And the processes in place right now just don't lend to a really affordable program over time. That could change as NASA changes its processes and whatnot, but it is a pretty clear admission that kind of the way this was set up, at least for the first few missions, isn't something that can go 10 plus 30 years over time into anything beyond double digits for Artemis moon missions over time.
Yeah, I have to say I had a bit of a choking moment when I read that the new streamlined, faster and cheaper to manufacture RS-25 main engines were going to be only $70 million after being 30% cheaper. That's a hard one to swallow, but it is the moon rocket we have, and we got to go with that. And
it works because they've already flown to the moon with one. So
that's right.
At least we've got
and
that.
It worked brilliantly. All right. Yeah. Finally, speaking of giant rockets, ...
That's right. Elon Musk's Starship may fly now in October, we think, for that second test flight. This came from the FAA, also from Elon Musk himself, and then we wrote about it at space.com. But the second orbital flight test is, as the SpaceX fans like to say, when hop, right? But the FAA handed down their initial investigation kind of summary that SpaceX had to complete 63 things, corrective actions. Elon Musk said this week that they've finished 57 of those, and the remaining 6 were for future flights. It was things they had to do to get beyond the upcoming test. So that sounds like they've checked all their boxes, and that it's just a matter of getting the final license from the FAA. We'll see, exactly how soon that can be. But an FAA official did confirm with us that they're looking at, or confirm with, I believe it was with CNBC, that they're looking at October as a possible target date. So we can stop holding our breath for that and focus on the returning samples from Bennu on OSIRIS-REx at the end of the month too.
Well, and in direct correlation to that, just a last little item here, NASA social or public relations or somebody has coined the term asteroid autumn, which I thought was very cute. We've got the OSIRIS-REx samples coming back from Bennu, of course. We have the launch of the Psyche mission and Lucy's flyby, help me with this, Anjani, of asteroid Dinkanish. Is that right?
I'm honestly not sure how you pronounce that.
I can just call it Dinky.
And I thought, is that Danish or Norwegian or what is it? Anyway, just the first of a number of asteroidal encounters, or at least 2033. So holy space rocks, Batman. It's going to be a wild autumn. All right.
It's also Batman Day tomorrow as we're recording this too. So that's a nice little double pun there, Rod. So
control yourself, my partner. We will be right back after a short break. Stay with us. This episode of This Week in Space is brought to you by Discourse, the online home for your community. For over a decade, Discourse has made it their mission to make the internet a better place for online communities. By harnessing the power of discussion, real-time chat, and AI, Discourse makes it easy to have meaningful conversations and collaborate with your community anytime and anywhere. Would you like to create a community? Visit discourse.org/twit to get 1 month free on all self-serve plans. Discourse is trusted by some of the largest companies in the world. It's open source and powers more than 20,000 online communities. Whether you're just starting out or want to take your community to the next level, there's a plan for you. There's a basic plan for private invite-only communities, a standard plan if you want unlimited members and a public presence, and a business plan for active customer support communities. Jonathan Bulava, developer advocacy lead at Twitch, says Discourse is the most amazing thing we've ever used. We've never experienced software so reliable, ever. One of the biggest advantages to creating your own community with Discourse is that you own your own data. You'll always have access to all your conversation history, and Discourse will never sell your data to advertisers. Discourse gives you everything you need in one place. Make Discourse the online home for your community. Visit discourse.org/twit to get 1 month free on all self-serve plans. That's discourse.org/twit. Welcome back. So, Anjani, can we start off just by you telling us what your role is with the mission and how you got there? Because I think it's always interesting for people to hear about how folks get into these jobs, because so many of us wanted to and most of us didn't.
Yeah, so I'm Anjani Polit. I'm the Mission Implementation Systems Engineer for OSIRIS-REx at the University of Arizona. OSIRIS-REx is actually led out of the University of Arizona by Regents Professor Dante Loretta. And so there's a whole team of us here at the University of Arizona that work on the mission. And of course, we have many other mission partners as well, such as Lockheed Martin and Goddard Space Flight Center. I work at the interface of science and engineering. So I'm not a systems engineer working with software necessarily or hardware. I'm working with science systems. So I get to work very closely with the scientists on the mission, as well as the engineers on the spacecraft team and navigation team, that type of thing. My background is in spacecraft science operations. Before working for OSIRIS-REx, I worked on the HiRISE camera on the Mars Reconnaissance Orbiter, which is this incredibly high-resolution, detailed camera system that produces these amazing images of Mars that launched back in 2006 and has been surveying Mars since that time.
So this is probably a bit of a stretch, but your job description reminds me a little bit of some folks I knew at Jet Propulsion Lab who were the interface for landing site selection for Perseverance, who had engineers over here and geologists over here and life science people over here and administration over here. And those voices didn't always speak the same language or want the same things. So it can probably be kind of challenging, I would imagine, at times, in a good way.
Yes, I mean, certainly challenging. Ultimately, though, we all want the same thing. So it's just a matter of, bridging those language divides from different backgrounds, the different companies and organizations and government entities we all work for all have different cultures. So it is about bringing all of these folks together, just making sure we get on the same page and come to those consensus solutions so that we can make the mission a success.
Well, I mean, they may need to tap you for some negotiation skills someday, but we'll let you get your mission done first.
And were you always interested in space exploration that led you to where you are now, or was that like an evolution of your studies as an engineer, and it was a different type of a progression?
So honestly, when I was young, I had no idea I could do something like this for a job. So yes, I was always interested in space in some way and in the sciences. And actually, I studied geology as an undergrad and then did a master's degree in geological engineering. And then I got a job doing the spacecraft science operations for HiRISE on the Mars Reconnaissance Orbiter. And so I've my path has diverged and done different things, but I've been working with spacecraft now for quite a while.
So we have a bunch of questions, but I'm just curious because I also did a minor in geology, and I'm kind of curious what got you interested in geology. For me, it was actually being able to look down and see firsthand the evidence of something that I was trying to understand.
Yeah, I would say once again, it was, I wasn't really sure what I wanted to do when I got into college. I had to pick a major. And actually, I did get interested in the geology because I took an intro class that was focused on planetary geology. And so it was that interest in space that kind of got me into that. And I was able to work with a professor in the geology department who did planetary geology, looked at Mars, looked at Venus, and studied the geology there.
Well, it sounds like you picked the right school for sure. So let's get back to the mission. Why Bennu? What makes Bennu such a great target? And what are you looking for?
Yeah, so OSIRIS-REx went through a really extensive search for the target for the mission. This is way back before I joined the mission when they were in the proposal stages. But they had to look for several different things. First, it had to be an asteroid that we could send the spacecraft to and come back from in a reasonable time frame. So that's why we did not send the mission out to the main asteroid belt. We sent it to a near-Earth asteroid, Bennu. It also had to be above a minimum size for navigation around the asteroid to ensure that we were confident we could go into orbit around the asteroid. And then finally, it had to be a carbonaceous asteroid, this carbon-rich asteroid. And so that's really how we got down to Bennu and selected that as the target for the mission.
And Anjani, I mean, it sounds like a lot has happened to get to this point. So I guess, you're about a week and a few days away from NASA dropping space rocks on the planet on purpose, right, Rod? So for science this time, not for anything else.
Excuse me, but yes, Dr. Clickbait, please proceed.
But can you explain? So you got to Bennu, you spent some time there with OSIRIS-REx, and that was amazing. But you collected samples, and so what's happening now on the 24th at like this kind of last mile for the mission that you're there to go oversee and watch come back with the rest of the team?
Yes, it's a very exciting time in the mission. This is the culmination of years and years and years of work. I've been on the mission for 7 years. There are people on this mission who have been working on it for almost 20 years now, starting from the first concept proposals that were proposed to NASA. So September 24th, that is in a week and a half, we are bringing back a sample from asteroid Bennu. And it's going to be really exciting. I will be out in Utah. It's going to land at the Utah Test and Training Range. That's Department of Defense land. It's used for weapons testing and other things. So it's actually, our landing ellipse covers both Army ground and Air Force ground. So we've been working really closely with our partners in the military to get ready for this milestone. And I'm happy to talk in a lot more detail about the details of exactly what's going to happen and in what sequence on that day.
Yeah, that's the part that I just can't imagine. I mean, it seems like one thing to get to an asteroid, but then you're coming all the way back again and hitting a target zone in the middle of the desert. So,
well, but not all was easy. So you got to Bennu, and there were a few surprises in store. It wasn't quite what necessarily was expected, and you took an amazing. And I mean, this is a big nod towards mission flexibility, which is something that I think NASA and its associates have done better than almost anybody historically, is being able to get somewhere and completely change the mission profile because, oops, this isn't quite what we expected. And we got to spend, I don't know, maybe almost 2 years trying to find the right spot to sample. So can you talk about that a little bit?
Right. So we had information on Bennu before mission launch. It had been studied with Earth-based telescopes. And so we had good ideas about its size, its rotation state, its mass, but that data was limited. And so that's why we had to go there and actually check it out for ourselves with the OSIRIS-REx spacecraft. As we were approaching the asteroid in the fall of 2018, we saw it go from a little pinprick of light to a world in front of us. And the big surprise there was that it was rocky and absolutely covered with boulders. The data we had from these Earth-based telescopes indicated that we thought there would be patches of sandy terrain where it would be easy to collect a sample from, but we got there and that was not the case at all. So that was one of the biggest surprises that we had to deal with, that we did have to rethink how we do sample site selection to pick that target area to get the sample. We had to switch to our backup navigation system for getting to the surface called natural feature tracking. And we had to add new capabilities to the spacecraft in the form of a hazard map so that the spacecraft could make some decisions as it was descending to the surface. And if it was predicted to hit an area that was designated as a hazard, it would make the decision to back away and not touch the asteroid. So this required people from all over the team coming together to try to solve these problems. And I got tapped to be part of the sample site selection board. And I originally was not supposed to have anything to do with it. And so I was thrown in there as we're all trying to figure this out. How can we actually make this happen? So that was just one of the surprises that we had when we got to asteroid Bennu.
So at what distance or range were you when you began to realize this wasn't primarily solid rock? And as part of that, observing the thermal changes as it moves and how fast it releases heat?
Right. So that type of data, its thermal inertia was one of the lines of evidence that we had that it was smooth and sandy in terms of, its resistance to heating up and cooling down. So based on that, we thought it was sandy. But as we were approaching and started to be able to resolve it and see those boulders sticking up and get closer and closer, we kept going like, well, okay, maybe there's some as we get closer, we'll be able to resolve, smaller features. Maybe it'll look okay. But as it turned out, no, it was just really rocky and sandy. But yeah, studying how it heated up and cooled down was definitely one of the things we were looking at.
We should point out too that OSIRIS-REx launched in 2016, and this collection part was back in 2020, and now here we are in 2023, and it's coming back. It's not a quick pit stop at an asteroid. I mean, a lot of planning by you and the team, went into making all of that right, and now into this big milestone of bringing the samples back. I mean, it sounds like there'd be a lot of risks for trying to hit that bullseye for landing, and I'm kind of curious, what are you watching and the team watching to make sure all of that goes okay?
Well, and just before she answers, Tariq, and on line 41, I've got a video clip of the actual sampling, which is pretty dramatic.
Yeah, we could definitely talk about the actual sampling too. Yeah, happy to.
I'm getting ahead of ourselves, Rad. I'm sorry.
Sorry, no, go for it. I just wanted to make sure he was able to bring that up. But yeah, please.
Yeah. So, well, okay, I'll talk about the sampling a little bit. So that happened in October of 2020. So actually, just going back, we launched in 2016. It was a 2-year journey to the asteroid, and then we essentially surveyed the asteroid for 2 years, and then departed the asteroid in May 2021, and it's been on its way back to Earth for the past 2+ years now. So that's just the overall mission timeline. So in October 2020, we executed the touch and go or tag event where we collected the sample. And that was one of those nail-biting moments in the mission as we were watching. The spacecraft was all pre-programmed. It had all the commands sent up ahead of time. So all we could do was watch and look at the telemetry and wait and see what happened. And this was another one of the surprises from the mission, was how Bennu responded to that touch event. We were coming down at 10 centimeters per second, about a 1/4 mile per hour. So it was a very gentle descent and touch. Okay. And then we blew nitrogen gas into the surface to direct sample into that sample canister, into the tag SAM head, the touch and go sample acquisition mechanism. But as you can see in the video, it just blew lots of rocks and dust everywhere. So as it turns out, we actually, the arm actually went into the asteroid about 50 centimeters. And it was only because the spacecraft thrusters fired, which was always a pre-programmed thing, but it was only because they fired that the spacecraft backed away. So it took almost 17 seconds for it to go above that surface height. And originally we planned it to be like a 5-second thing. So it took a while for it to actually back away. It meant we got lots of sample, but yeah, the rocks were just these fragile, friable things and there was no cohesion really. So if we hadn't fired those back away thrusters, OSIRIS-REx probably would have been swallowed whole by the asteroid.
It's like quicksand in space.
It is. It's fascinating to see because I think most of us, and certainly the lay public, of which I'm part admittedly, when we first heard about this mission, thought, oh, okay, they'll have a soft touchdown, little sampler scoop will go, like we saw on the moon and on Mars, sampler scoop will go down. It's like, no, you make this quick contact, gather just enough and boost back. And as I understand it, a small rock got caught in the sample canister and blocked it from closing completely when it first pulled away, right?
That's correct. That was another surprise, an issue that we had to contend with. We were actually so successful in the sampling that a rock got in there and jammed open the flap that was supposed to close and keep the sample from escaping. So when we took images of that sampling head, and we could see evidence that there was a lot of sample in there, but then we saw these little particles coming out from the sampling head. And yes, that was quite a moment at first it was like, whoa, we got sample. And I was like, wait a minute, what's happening here?
It's dribbling out. Yeah.
So we did a quick decision to stow the sampling head. We did not do the planned sample mass measurement that we had, that we'd rehearsed and were planning on, and instead decided that we needed to get that stowed as soon as possible.
It's always astonishing, and I've been fortunate to be able to sit in on a couple of these sessions, but to watch the engineering and science teams try and solve these problems, especially on the engineering side, because I can only imagine if you're sitting there staring at your charts and talking to your colleagues, and there's just this little child inside of you that just wants to reach up and grab that damn spacecraft and wrench that door closed and be done with it. But no, you've got to spend hours, days, weeks. I remember one case particular in Viking, the Viking Mars lander, they were trying to release the sampling arm because a pin hadn't pulled out. I don't remember, I think it was a pyrotechnic thing. And it took a week of rattling the motor on the thing to get the darn pin to drop. It was like a grenade pin almost. And so the calisthenics that you folks go through is astonishing to me. So Tariq, I think this is bringing us to your infamous line 37 question.
I guess before that, because I'm very interested in what you're bringing back on OSIRIS-REx. Is there an early estimate, if you didn't do that mass measurement, to know how much material that of Bennu OSIRIS-REx collected?
Yes, so we have a brilliant spacecraft team, and they did manage to still make some estimates just from what it took to move the arm when we did move it and stow it as well. So even though we were losing particles and we couldn't do the precise sample mass measurement we had, which we had planned, which was essentially sticking the arm out and then pirouetting the spacecraft around to measure that momentum change. Anyway, we did not do that for that, but we still got some estimate. So we think we have about 8.8 ounces or 250 grams of material. That's about a cup full of material that we think we're bringing back, but there is still significant uncertainty on that. So that'll be one of the really exciting things to see when we get the sample back here on Earth, is exactly how much did we bring back.
Well, and that's great. And I mean, that's a very nice visual. I can imagine my coffee mug filled with asteroid stuff. Then the other question that we get is, about contamination and how, I guess also
on. Read it the way you said it. Space plague. How do we know it's not a space plague? I saw that on there.
So yeah, I get asked that a lot. How do we know we're not bringing back stuff from space, critters or diseases like from the Andromeda strain? And I assume that you have a plan for that to both protect us, Earth, and protect the sample from us when it comes back too. I'm sure you don't want to contaminate it once it comes back down either.
Right. That's an important question. And of course, NASA takes planetary protection very seriously. We're actually worried more about us here on Earth contaminating the sample. Because asteroid Bennu has been out in space without an atmosphere for billions of years, it's been subject to that harsh, sterilizing radiation environment. So there are no concerns about us bringing back anything bad to us here on Earth. Rather, we need to protect the sample from us so that when the scientists are studying it and analyzing its mineralogy and chemistry and physical properties, we know that what we're finding out is about Bennu and not something that we accidentally contaminated from us to the asteroid or to the sample that we brought back. So there are measures in place. It's been part of the plan from the very beginning in terms of how do we measure and make sure we control for contamination. When the sample lands on the ground, we're going to collect it very quickly, bring it to a clean room. In Utah, we are going to get the sample canister on a nitrogen purge so that it doesn't get to interact with the oxygen in our atmosphere and start changing the sample. And then we're bringing the sample from Utah to NASA's Johnson Space Center, which has built a special facility specifically for this sample. And it will be housed there, and the sample canister will go into a specialized glove box, again, where it's going to be on this nitrogen purge. And as the curation team at the Johnson Space Center starts disassembling parts of it and gets the sample out, they will be doing that through these thick gloves into the glove box. So nobody's going to be touching that sample.
Well, I just want to point out that having grown up in the 60s and early 70s, that I used to go to Saturday matinees when they actually showed movies, science fiction movies that all the kiddies wanted to see. And there was usually some silver-haired guy in a military uniform saying something like, "Nothing can go wrong. We have countermeasures in place." And what you're seeing on the screen now, if you're watching the video, is a clip from very possibly the worst film about intergalactic goo ever made. It was actually called Green Slime. Anjani, I want to point out that it was a Japanese film that was dubbed into English, and the monsters, you see a clip of the eye there, were large green plastic bags with tentacles with car flares in the tips. So this was high drama, and it was probably one of the worst films ever made. I think we've seen enough of that. Before we go to the break, though, and we do have to take another break, but I wondered if you could comment on the spotting of hydrated minerals on Bennu, because that was probably a bit of a surprise.
We actually did think that there were hydrated minerals on asteroid Bennu, but as we were approaching and we started using the imagers, the cameras, and the spectrometers on the spacecraft, we did actually fairly quickly get that detection of hydrated minerals on the surface, which was really thrilling to see. And so that is the water is locked up in the mineral structure in these phyllosilicates or clays. And so, one of the reasons why we study asteroids like Bennu and why we want to bring the sample back is asteroids like Bennu are time capsules from the early solar system. And so asteroids like Bennu could have delivered water to the early Earth and could have delivered organic molecules to the early Earth. So we picked the right target, and we're excited to see what we actually bring back.
Fabulous.
And you got so much of it, right? You got a whole cup full. That means that I could have a piece, right? I mean, if there's overflowing.
Why, what a fine moment to go to a break. We'll be right back after this quick break so that Tariq can try and beg some more asteroidal material off of our honored guest. We'll be right back. This episode of This Week in Space is brought to you by our friends IT Pro TV, now ACI Learning. Our listeners know the name IT Pro TV is one of our trusted sponsors for the last decade. As part of ACI Learning, IT Pro TV, now IT Pro, has elevated their highly entertaining, bingeable short format content with over 7,200 hours to choose from, and new episodes are added every day. ACI Learning's personal account managers will be with you every step of the way. Fortify your expertise with access to self-paced IT training videos, interactive practice labs, and certification practice tests. One user says, "It's an excellent resource, not just for theory, but labs incorporated within the subscription. It's fantastic. I highly recommend the resource and the top-class instructors." And don't miss ACI Learning's practice labs, where you can test and experiment before deploying new apps or updates, all without compromising your live system. MSPs love it. You can retake practice IT certification tests so you're confident when you sit for the actual exam. ACI Learning brings you IT practice exam questions from Microsoft, CompTIA, EC Council, PMI, and many more. Access every vendor and skill you need to advance your IT career in one place. ACI Learning is the only official video training for CompTIA. Or check out their Microsoft IT training, Cisco training, Linux training, Apple training, security, cloud, and much more. Join ACI Learning on September 26th and 27th in London at the International Cybersecurity and Cloud Expo to experience the latest innovations and cutting-edge technologies. You can learn IT, pass your certs, and get your dream job. Or if you're ready to bring your group along, head over to our special link and fill out the form for your team. TWiT listeners receive at least 20% off an IT Pro Enterprise solution, and you can reach up to 65% off for volume discounts depending on the number of seats you need. Learn more about ACI Learning's premium training options across audit, IT, and cybersecurity readiness at go.acilearning.com/twit. For individuals, use code TWIT30 for 30% off a standard or premium individual IT Pro membership. That's go.acilearning.com/twit.
You have outlined how the samples are going to be, kept safe, both, after landing and then I guess for the future for study. But they have to get to Earth first. And you mentioned going through Earth's atmosphere. And it sounds like whenever there's a landing like that, there's a lot of risk involved. And I asked that question earlier, and then we were mesmerized by the actual sample collection, which, rightly so. That was amazing. But I did want to make sure that we had a really clear idea of exactly what you have to protect. You and the team have to protect OSIRIS-REx against. You're slamming into the atmosphere. You have parachutes that have been, locked away for years now at this point that have to go right. And if you can walk us through what that process is going to be like, maybe where you and the team are going to be watching all of that come back, that'd be great to kind of get an idea of that.
Right. Yeah, it's going to be a bit of a nerve-wracking day on September 24th. So the day actually starts really early in the morning, and I'm going to give times in Mountain Daylight Time since we're going to be in Utah in Mountain Daylight Time. So at 2 a.m. Mountain Daylight Time, the spacecraft team, which is actually outside of Denver, Colorado, they will be getting ready to send the final commands to the spacecraft. There'll be a go, no-go meeting where the final decision is made about whether we can release the sample return capsule. And that will be made on several grounds. We have to make sure that the spacecraft is ready, that the Utah Test and Training Range is ready, and we have to ensure that it's going to land in that pre-designated landing ellipse, and that the sample return capsule, based on the predictions, will survive that entry. So it should be a go. That's what we're expecting, but we have to make that final decision. Then the spacecraft team will radiate those commands to the spacecraft, and the spacecraft will release the capsule at 4:42 a.m. Mountain Daylight Time. That's 4 hours before it's going to enter the atmosphere. And it's going to spin up that capsule, so it's rotating about 13 rotations per minute, and the capsule is going to be on its way. The spacecraft is going to execute a divert burn so that it passes about 500 miles from the surface of Earth, and keeps on going. And we can talk about that part later.
Yeah.
But then the capsule is going for 4 hours. Then it enters the atmosphere at 8:42 a.m. Mountain Daylight Time, and it goes on a 13-minute journey through the atmosphere to land at around 8:55 a.m. Mountain Daylight Time. So, right, entering the atmosphere, that's a scary thing. It is going to be going more than 27,000 miles per hour when it enters the atmosphere.
Yeesh.
And we have, of course, a heat shield to protect the sample inside and ensure it doesn't get too warm. But we have to make sure the spacecraft lines up the capsule so it enters exactly at the right angle. So that's one of the things we have to do with the spacecraft. And then the capsule will start decelerating. It will release a drogue parachute to stabilize that descent through the atmosphere. And then about 5,000 feet above the ground, it will release the main parachute, which is about 24 feet across. And that main parachute will slow it down even more so that it lands at about 10 miles per hour, going from 27,000 miles per hour to about 10 miles per hour when it touches down. So I think the most nerve-wracking part of that is waiting for the main parachute to deploy. We have every expectation that it will work. This is based on heritage from the Stardust mission, which was more than 15 years ago at this point. But the team did lots of testing before launch, all of that. But still, that is the moment where I think we are all going to be waiting for, waiting to see that main parachute deploy. And I'll start breathing a little easier at that point. And then, of course, I'll feel so much better when I see it safely on the ground.
And just a real quick follow-up. Sorry, Rod. You mentioned giving it a go to separate. Is there like a chance to go around? Let's say there's like a big storm over the entire landing site and you can't separate. Do you get a second chance to come back, or is that really the only try?
So there is a second chance. We would have to wait a full 2 years for that. We really don't want to do that because also the spacecraft will be going closer to the sun than is great than we'd like during that 2-year time period. So we really do want to separate and release the capsule now this time. And you mentioned the weather. So actually the weather at the landing ellipse is not a factor in that decision. It's better to get the sample on the ground, even if the recovery team has to wait a little bit before they can actually reach the capsule. So it's better to get it on the ground rather than having it sit in space and get heated up over the next 2 years.
Got it. Thanks.
And is this a straight ballistic entry, or do you glide and guide a bit as you're coming in?
No, so there's no control on the return capsule itself. It's up to the spacecraft to get it lined up, to spin it up, release it, and then that's it.
Wow, like a bullet. So we're used to, I've written a few books about not this mission, but about the Mars missions and so forth. And so if you've spent time looking at that, as I'm sure you have, we're used to robots in other worlds doing these investigations. We're not used, except for the Apollo program and a few other lunar samples, we're not used to having the luxury of bringing this stuff home and putting it in a lab and bringing in machines 3 times larger than the spacecraft that just look at one component of it. What kind of investigations? This is probably a separate episode of its own, but just, for a brief for us, what kind of investigations will we be doing on these samples? And who, by the way?
Yeah, so that is a really exciting aspect of this. This is NASA's first asteroid sample return mission. So not only did we get to study the asteroid up close with these wonderful instruments on the spacecraft, we get to bring that sample back here on Earth and distribute little bits of it to many members of the science team, and we get to use the amazing labs and instruments here on Earth. So we have more than 200 members on the science team that have been getting ready to study these samples. Most of them have lots of experience in studying meteorites, so that we get to use those same techniques now on this fresh asteroid sample. And there are more than 60 different analytical techniques that folks are going to use to study the sample. I think you're right. You could go into the details of this and talk for a long time to some of the members of our science team to learn about all of the different details. But I mean, we'll be studying, of course, the mineralogy, the chemistry, its physical properties, trying to gain insight into that early time in the solar system, Bennu's history, and importantly, comparing what we learn from the sample here on Earth to what we learned with the spacecraft and the instruments at the asteroid. One of the things I'm most excited to see is just how similar or different the sample that we're bringing back is to the meteorite collection we have here on Earth. Is this going to be something that's completely different? Is this something that's similar to some of the carbonaceous chondrites that we have here on Earth? Things like that.
Well, that the trail of backscatter from just what you'll understand there must be huge, because you've got thousands of pounds, tens of thousands of pounds of meteorites collected over the years everywhere, including the Antarctic, where you find lots and lots of them. So what you understand in that kind of one-to-one comparison is probably going to rewrite how all those things are looked at, I would assume, right?
Exactly. I think so. And one of the really amazing things about sample return missions is the sample analysis team will study up to 25% of the sample that we bring back. And then we have agreements to give 4% to the Canadian Space Agency and 0.5% to the Japan Aerospace Exploration Agency, or JAXA. But then the vast majority of it is going to be saved for study in the future. And so scientists who are not even born now might get to analyze this in the future using techniques that have not even been invented yet. So it's a gift that keeps on giving in terms of its science return.
So Tariq, I think your quarter cup is spoken for. Sorry, buddy.
I guess so.
You're just going to have to be happy with that.
I will donate it to science, right?
Okay. So I know you've got a burning question, and we will be right back to hear it after this quick break. Stay with us.
So Anjani, sorry, I was thinking about my question right there. No, you mentioned the team in Denver, commanding the spacecraft, but you're going to Utah, and it sounds like the OSIRIS-REx team is going to be a bit spread out, and as opposed to like when we watch the Perseverance rover land, and everyone is in like the operations control center and cheering and everything. So I'm curious how you and the on-site team, are you going to be in a blockhouse somewhere? How are you communicating with the folks back in control? And then finally, how are you planning to celebrate once you get news of the landing and how it all went?
Right, that's a great question. We will be spread out in a bunch of different locations. We'll have the spacecraft team located in Denver. There'll be members of the science team located all over the place, all over the world. There'll be some folks here in Tucson, Arizona, at the University of Arizona, who are going to gather to watch the NASA live broadcast. And then for those of us in Utah, it's actually a small subset of the team. It's really just the folks who are involved in sample recovery. I'm a backup on the recovery team, so I've gone to all the practices, all the trainings, but in the nominal scenario, I am going to be in the operations room watching the recovery team do its work, and will be in radio contact with them in case any issues come up or they want to consult with the folks in the operations room. We'll be able to do that. So everyone's going to be laser focused on getting that sample capsule bagged up, recovered, and brought to the clean room, and then getting that to the Johnson Space Center as quickly as we can. Once we get it to its specialized facility and safely stowed, then we can start thinking about the celebrations. And we are actually going to have a team gathering in Houston to celebrate. Yes.
So in years past, and I'm saying years past, be ancient history to you, 70s and 80s, these missions, while there were always collaboration with industry and academia, the action was primarily at places like Jet Propulsion Lab. Now the center of mass has shifted, and the universities have a lot more interaction and control, with something like, the Mars Phoenix mission actually having their mission control at the university, which I thought was stunning and brilliant. Can you talk a little bit about how that works and why it works so well? Because it really has turned out to be just an extraordinary way of doing business.
Right. So these are principal investigator-led missions, which means the principal investigator could be at any number of types of institutions. And I'm actually sitting right now in the building that the Phoenix Mars mission was run out of.
Oh, really?
Yes. That's what this building was used for first. So it is really great. And by having a mission run by a professor here at the University of Arizona, that also gives us a great way to bring in students and get students exposed to this, students in science, students in engineering. So it's a great way to educate the next generation. And I do think it just brings a whole lot of people together in ways, and we make use of all the talent and knowledge that we have. So yeah, I work at the University of Arizona, but we work with NASA's Johnson Space Center. We work with Goddard Space Flight Center. Goddard provides the project management. Johnson Space Center they're the curation experts for astromaterials. Yes, we work with Lockheed. We work with Kinetics Aerospace to do the navigation. So we work with a lot of different partners, and it's been fantastic because we use everybody's knowledge and we all come together as a team to solve the challenges that we have.
Given the challenge of this mission, I mean, that's one thing, but you mentioned something earlier too about the spacecraft itself, that it's going to keep going and that it might have a future. And I had heard that it may even have another asteroid target in mind. And I was hoping you can kind of walk us through what happens next. Does it just kind of go to sleep for a while and say farewell to Earth forever? Or will we see it again? I guess not, right?
So as I mentioned, about 20 minutes after it releases the capsule, the spacecraft will perform this divert burn to send it on its way to its next target, which is asteroid Apophis.
Apophis? All right.
Yes, the infamous Apophis. It's a really exciting mission, and I'm so thrilled to be part of that as well. So the spacecraft has a 6-year journey to get to asteroid Apophis, right? We have to swing around the sun a bunch of times, line up the orbits, and in 2029, in April, asteroid Apophis will make a very close pass by the Earth. There's no chance it will hit the Earth, but it will pass about 1/10 the distance from the Earth to the Moon, which is really close. It's a really exciting opportunity. And Earth's gravity is going to tug on the asteroid. And we get to study what changes that will have on Apophis. And so it will definitely change its orbit drastically. We know that. It might change its rotation rate, or the length of its day. And it might also do things like create landslides on the surface from that tug as it passes by Earth. It's a really, really exciting extended mission, and that's called OSIRIS-APEX. APEX stands for Apophis Explorer in this case.
And it's easier for us journalists, Tariq, because it's all caps this time. So
right.
We don't have to remember where it changes to lowercase. Sorry, go ahead.
But is it going to be a flyby then, or will OSIRIS-REx kind of tag along for I guess the foreseeable?
Yeah, it will be a full rendezvous.
Oh, wow.
So it's really incredible. We will actually, the OSIRIS-REx spacecraft, or now OSIRIS-APEX, will swing by the Earth just after Apophis does, and then it will approach Apophis in the month or so later, and then actually it will go into orbit. It will perform a bunch of flybys to map Apophis from every angle and from all of these different solar illumination geometries. So yeah, it's a full rendezvous mission. It's great. We'll spend about 18 months studying it.
Was that always the intention, or was this something that was added later?
This was added later. We were all so cool. Very focused on the prime mission. And I was actually in the first meeting, that first presentation where we had a mission designer who had been looking for possible targets. And they figured this out and presented it to the principal investigator. And I just remember everyone was like, what? Really? We can study Apophis? It was really exciting to learn that.
This is like one of those Star Trek moments that they realize, oh, if I push this button over here, there's gravity in the ship. Okay, Tariq, I'm giving you the last question, which I want you to read verbatim off of line 53 because only you would say this.
Well, I was in my defense, Anjani. I have a reputation for always asking like the emotions question, right? How does it feel to do this, or how does it feel to be back on Earth, right, for the astronauts or whatever. And so in my note taking, I just wanted to ask like what sort of feels you and the team are going to have for this. It wasn't meant to be spoken aloud, Rod, but it's a good question.
Sorry.
To ask. I mean, because it's the end of the road of sorts of a big, part of your life, of your team's life, right? To get to this milestone. It's not the end of the mission. You just outlined that, obviously. But it feels like a major moment. And I'm just kind of curious how you expect or to feel or not, even to wait to kind of process everything once the canister gets opened for the first time in, I think NASA said October, I believe, is the announcement that came out this week. I'm just curious if that's something that you've been thinking about and preparing for, or if you're going to wait and see.
I guess it is sort of impossible to know exactly how we will feel at the moment, but I can tell you that already now in these months leading up to sample return, it's been emotional. It's kind of surreal that we're here at this point in the mission, something we have been working towards for a really, really long time. And each rehearsal that we've done, rehearsing all the steps of the recovery, it's felt more and more real. So I'm thrilled. I'm a little bit nervous, but also very confident in the team. And I just can't wait to see that capsule on the ground in Utah.
And I'm not sure if Tariq intimated this, but are you staying with the mission for the next target?
Yes, I am. I'm very fortunate that I get to
great.
be involved in OSIRIS-APEX as well, and I'm really excited to be part of that.
It's going to keep an eye on Apophis for us.
Man,
right?
what a great career. All right, well, I'll stow my envy for now, and I want to thank everybody for joining us for this preview of what to expect. Mark your calendars, September 24th, OSIRIS-REx comes back, and we have samples in hand. Anjani, where can we keep track of your activities besides the OSIRIS website, which we will put up in our show notes?
Well, I would like to recommend that people watch the NASA live broadcast that's going to happen on September 24th. That will start at around 8 a.m. Mountain Daylight Time, and you will get to watch and follow this live as the capsule comes in on the parachute and the recovery team goes out there. So definitely do look at that as well as of course, the NASA OSIRIS-REx website.
And I'll bet that'll be carried live on space.com, right, partner?
That's right. That's how I like to spend every Sunday, is with an asteroid landing. So asteroid sample landing. So
all right,
I'm excited.
Tariq, where can we find you dropping samples these days? That didn't come out right.
As always, you can find me on space. Oh man. I went to graduate school, Rod. So, no, but you can find me.
Hey, so did I at a better school than yours, my friend. Yes, we can find you at space.com and on the Twitters. And
on the Twitter at Tariq J. Malik. And just looking to the next big thing, watching OSIRIS-REx bring those samples back and head off to Apophis.
I guess we're going to have to start saying we can find you on X.
X, formerly known as Twitter.
So wrong.
Is the official.
And of course, you can always find me at pylebooks.com and at astromagazine.com. Please don't forget to drop us a line at twit.tv. That's TWIS at twit.tv. We love getting your comments, suggestions, and ideas. We read every email, and I answer most of them because Tariq's a busy guy. Also, don't forget to check out space.com. The website's the name, and the National Space Society at nss.org. Both are great places to fulfill your meandering spaceflight cravings. New episodes of this podcast publish every Friday on your favorite podcatcher. So be sure to subscribe, tell your friends, and give us reviews. We'll take 5 stars or a thumbs up or 3 puppies or whatever the equivalent rate of trade there is.
3 puppies.
And you can also head to our website at twit.tv/twist, TWS. Finally, don't forget, you can get all the great programming on the TWiT network ad-free on Club TWiT, as well as some extras that are only available there. That includes a bunch of really good shows that you can only get there for just $7 a month, which is cheaper than streaming the movie Ad Astra off of Amazon, and infinitely preferable because it was a horrible, awful movie, despite the fact that I like the name. I mean, unless you want to watch Brad Pitt go across the solar system to solve his daddy issues, which didn't really work out very well. You can also follow the TWiT Tech Podcast Network at TWiT on Twitter and on Facebook at twit.tv and Instagram. Thank you, everybody. Thank you, Anjani. Thank you, Tariq. Thank you, Ant. We'll see you next week.
Oh, hey, that's a really nice iPhone you have there. You totally picked the right color. Hey, since you do use an iPhone and maybe use an iPad or an Apple Watch or an Apple TV, well, you should check out iOS Today. It's a show that I, Micah Sargent, and my co-host Rosemary Orchard host every Tuesday right here on the TWiT network. It covers all things iOS, tvOS, HomePodOS, watchOS, iPadOS. It's all the OSs that Apple has on offer, and we love to give you tips and tricks about making the most of those devices, checking out great apps and services, and answering your tech questions. I hope you check it out.